Hello student, today we will discuss the topic covalent bond, and that is the second part of covalent bond. Now, as we know that for attendance stability, each and every species means it may be atoms, molecules or ions, try to attain 8 electrons in the last orbit, that is valence shell. So, in order to attain 8 electrons in the last orbit, elements try to two-phase. The first is by the sharing of electrons. In the second page, by the complete transfer of electron. Now, first, we will be discuss the first page, means by the sharing of electrons. If both elements are non-metals, it means they have valence electron is 4, 5, 6, 7 or 8. Then here is the possibility of sharing of electrons. If both elements are non-metallic. Example, if we are taking the example of carbon, its atomic number is 6 and its electronic configuration becomes 2, 4. It means it contains 4 electrons in the last orbit. So no doubt it is a non-metal. Now next is nitrogen, 7. Its electronic configuration becomes 2, 5. Here is the 5, its valence electron of nitrogen. Oxygen, 8, that is 2, 6. It contains 6 valence electron. Fluorine, 9, 2, 7. It contains 7 valence electron. Neon, its atomic number 10, contains 8 valence electron. So all these elements are called non-metallic elements. Let me discuss example. If we are taking the example of carbon, as we know that it has 4 valence electrons, that is represented by the cross. These 4 cross represent the 4 valence electron of carbon. Now, for attain the stability, carbon requires 8 electrons in the last orbit. So, here is the 2 page by which carbon having 8 electrons in the last orbit. The first, it gained 4 electrons from another species. But here is the problem. The problem is that gaining of 4 electrons, it's not an energetical favorable terms. Since any element or any atoms gain maximum 3 electrons. After 3 electrons, that is 4, 5, 6, 7, 8 or more, the process is not energetical favorable. So this process is not happen for the carbon. So carbon never gain 4 electrons to complete its octet, since it is not a energetical favorable term. Now in the second page, in order to complete octet or 8 electron in the last orbit, carbon shared its 4 electron with another atom. This like carbon is 4 electron and shared with Cl, Cl having 7 electrons in the last orbit. These 7 dots represent 7 electron or 7 valence electron of the Cl. Again here is Cl, it's 7 electron. Here again Cl, it's 7 electron. Here one more Cl, again 7 electron. In that case, for attain stability or attain 8 electron in the last orbit, this carbon shared 1 electron with this Cl Next electron again shared with this electron, third share this electron, and last fourth share with this electron. After sharing, carbon each Cl having 8 electrons in the last orbit. We will also represent of this type. This one is carbon having 4 electrons in the last orbit, 4 cross. Now Cl, this block for the Cl having 7 electrons. This 1 electron is shared, remaining 6 electrons is intact. This one is this type. Now here is the again Cl, this electron 2, 4, this 6. There is again Cl, this dot. Now 1, 2, 3, 4, 5, 6. There is one more Cl again. 1, 2, 3, 4, 5, 6, 7. Now these 6 electrons around each Cl atom. The 6 electrons, these 6, and these 6 are called lone pairs. That is LP, lone pairs. Now lone pair means a pair of electrons that will not involve in the bond formation. And these 2 electrons, that is called bond pair. Similarly, this one is called bond pair. Here is this is the bond pair. Here is again bond pair. Here is the bond pair. And bond pair means a pair of electrons that involve in the bond formation. So this one is the molecule of CCl4 equals to CCl4, that is carbon tetrachloride. Now in this example, carbon and Cl both complete their octet by sharing of electrons. Now after this example, we will define covalent bond. So definition of covalent bond. A bond or a chemical bond which is formed by the sharing of electrons by the sharing of electrons called covalent bond. Non-metallic elements. Now after this, we will classify the covalent bond. Now classification of covalent bond. So the first criteria is on the basis of number of covalent bond. The first one is single covalent bond. It is formed by the sharing of one electron pair.
One electron pair. That is one bond pair. Example. The simplest example is hydrogen H2. This one is hydrogen with single electron. Another hydrogen with single electron sharing one electron, or hydrogen, another hydrogen sharing one electrons. Now we are taking the example of Cl2.
In Cl2, each Cl having 7 electrons in the last orbit. This Cl again sharing 1 electrons, or maybe this type Cl, another Cl, this type. The second one is double covalent bond. It is formed by the sharing of two electron pairs, formed by the sharing of two electron pairs. For example, O2, oxygen. In O2, each oxygen having 6 electrons. In the last orbit, the oxygen is 6 electron. Another oxygen having 6 electron. So these form, and these are called lone pair. This is the O double bond O. Third is triple covalent bond. It is formed by the sharing of 3 electron pair. For example, we are taking the example of nitrogen, that is N2. Here is the nitrogen, contain 5 valence electrons. The nitrogen 5 valence electrons. To complete octet, shared 3 electrons from each side. Now the diagrammatic representation is that nitrogen, another nitrogen, with 1, 2, 3, 4, 5. From this side, 1, 2, 3, 4, 5. So this one is the complete nitrogen molecule. These 6 electrons are called bond pair. Here is the 3 bond pair, and this one is called lone pair. This is also called lone pair. So we will classify covalent bond in 3 types on the basis of number of covalent bonds. More than 3 covalent bonds formation is not possible since covalent bond formation process occurs at the axis, and as we know that only 3 axes are possible, that is x, y and z. So at a time we cannot form more than 3 covalent bonds. We can form maximum 3 covalent bonds. Okay, now next time we will discuss next basis for the classification of covalent bond. Thank you.